In the name of God, hello dear students, welcome back to Faircloth's website. My name is Masood, I'm a physics teacher. We are in Faircloth's website to explain physics curriculum grade 11. In previous lessons, I told you that there are 4 rules. In our textbook, at least in our textbook, there are 4 rules that are devised for motion with constant acceleration. Maybe you search for other sources, you find more than four rules, but in our textbook, only 4 rules with constant acceleration are mentioned. And the source is our textbook. We just concentrate on these 4 rules. Firstly, before we reach some problem and practice, we prove the rule. After the proof, actually, we solve the question, we solve the problem, right? So, in previous lesson, I proved one rule for you, and we solved problems regarding that rule. Right now, we are going to prove the second one. Let me read actually the text of the second rule or second law. Final velocity depends on initial velocity, acceleration, and time. Time interval. Right. Final velocity means v final. Depends on initial velocity. Depends on initial velocity, v initial, acceleration a, and time interval delta t. So we look for a rule. We look for a rule. Rule starts with the final, and the rule includes the initial velocity, acceleration, and time. Or in other words, we search for a rule. Let's say it starts with Vf in terms of initial velocity, acceleration, and delta t. Right. So we want to start the proof. This is the first step from the definition of acceleration. Just bring the definition of acceleration that we got it before. Acceleration is equal to v final minus v initial divided by delta t. Cross multiply the equation above leads to. Cross multiply this equation. And I told you, let's say about the multiplication. Cross multiplication means you have to multiply the numerator of one side by the denominator of the other side. That's why you get in order to open the fraction, in order to change the fraction into the linear equation. Yeah? This is called cross multiply, cross multiplication, or so after cross multiplying the fraction, you get this form, right? V final minus V initial is equal to A delta T. The last step, I want you to bring initial velocity from the left side to the right side. Transfer it from the left side to the right side. And that's why whenever you move it to the right side, its sign changes to positive. That's why the last form of the equation, V final is equal to V initial plus A delta T. And we got our actually we reached our goal. Yeah, we look we looked for the rule for v final that includes these factors, and this is the result of our proof. Right. The third one, the third one, displacement depends on initial velocity, acceleration, and time. Displacement means delta x. We look for a rule for delta x in terms of the initial, acceleration, and time interval, right? So there are three factors. The rule for delta x should include these factors, right? Let's start our proof from these equations, right? What's the equation? The equation that we proved that, let's say, 2 or 3 minutes ago, v final is equal to v initial plus a delta t. This is the, so we numbered as number one, equation number one. Equation number two, this is the first law that we proved it in previous lessons. Delta x is equal to 1/2 bracket vi plus vf within the bracket actually delta t. So you are familiar with these rules, right? Number one and number two. Substitute equation number one into the equation number two. So substitute this equation, v final is equal to v initial plus a delta t, in equation number two, because we don't need final velocity. If you take a look at the text, it says displacement depends on initial velocity, acceleration, and time without final velocity. That's why whenever you substitute this law, right, this law for final velocity, in the law of displacement, final velocity uh, will be disappeared, and actually we are going to prove the law without let's say final velocity. That's why we substitute number one into the number two. Right. Delta x is equal to 1/2. So after substitution, let me explain for you. Bring question number two here, equation number two. Bring equation number two here. So delta x remains as it is. 1/2 remains as it is. Initial velocity remains as it is, right? So 1/2 delta x, they are actually remained unchanged. But in place of final velocity, you have to substitute this value, right? In place of final velocity, you have to write vi plus a delta t. But outside of the bracket, we have delta t. You have to mention it here as well. So uh, I can say delta t mentions without changing. So only one thing changes, only final velocity does not remain uh, as it actually as it is, right? Delta x is equal to 1/2 vi, and vi are, let's say, they are identical terms. So vi plus v becomes 2vi plus a delta t inside the bracket, and outside of the bracket we have time interval delta t. I want you to multiply the 1/2, let's say, into the each term within the bracket. So it will be 1/2 multiplied by 2 becomes actually vi, because anything, any fraction multiplies by its invert, the result will be 1. That's why vi remains without any fraction, because 2, let's say, simplifies with 2 plus 1/2 multiplied by a delta t. Here, when 1/2 becomes a coefficient of a delta t, and the second delta t remains outside the bracket. So right now, this is the last step. You have to multiply the time interval outside the bracket, right, by each term within the bracket to get the final form, right? Let me show it to you. This is the final form. So right now I want you to multiply. We reached this step. We reached this step. Multiply delta t firstly into the vi delta x, so vi delta t plus 1/2 a delta t times delta t. Delta t times delta t becomes delta t squared. And this is the last form of the equation. Let's take a look at the text to make sure our proof is actually equivalent. Our proof is corresponded to the text. Let's check it together. It says displacement, delta x, depends on initial velocity. Yeah, initial velocity. We have initial velocity here. Acceleration, yes, we have acceleration within this equation, and time interval, That's why uh, this equation um, actually is coincide. This equation coincides with uh, our text. That's why we reached our goal, and this is the third. This was the third equation for motion with constant or uniform acceleration. Thank you so much for watching this video, and bye for now.